Simple pendulum lab design. The simple pendulum consists of a bob hanging from a light string. You wish to experimentally determine the relationship between the period and mass of the pendulum bob. You record the time t it takes to make 10 oscillations, the mass of the pendulum bob m, and the angle theta at which the pendulum is released. You repeat the experiment several times. The results of the trials are recorded in the data table. A. Which trials will you use to analyze the relationship between period and the mass of the pendulum bob? Explain your reasoning for choosing these trials. B. Sample data are in the table on the next slide. You want to plot the data to determine the relationship. The table includes space to calculate any values needed for the graph. Ensure that the graph's axes are labeled and are scaled properly. Here's the trial data. We have trials in that direction. Here's the angle theta we set the pendulum for, the mass of the pendulum bob, and the time it took for 10 oscillations. Using the graph, determine the relationship between the period and the mass. Explain your reasoning. D. You now hypothesize that the period of the bob is linearly proportional to the length of the string. You select 5 strings of different lengths, each attached to an identical mass, to test your hypothesis. 1. How does the previous experimental procedure need to be modified to test your new hypothesis? Explain your reasoning. Describe an experimental procedure to test your hypothesis. Describe at least one way to minimize experimental uncertainty. And 3. How would the data be analyzed to test your hypothesis? Explain your reasoning. Which trials will you use to analyze the relationship between the period and the mass of the pendulum bob? To determine the relationship, all other quantities should be held constant so they have the same effect for each trial. The only other measured quantity is the angle theta, so that should be held constant. Trials 1, 3, 5, 7, 9, and 10 have the same angle, 5 degrees, and they also have different masses for each trial, which minimize the overall experimental uncertainty. The experiment was set up properly with all angles less than 15 degrees, so the pendulum would oscillate in simple harmonic motion. You want to plot the data to determine the relationship. The period of the pendulum bob was found by dividing the time, that's this row right here, by the number of oscillations, which were 10. A period mass graph is then plotted to determine the relationship between the two quantities. Here's our graph. The y-axis is period in seconds. Make sure you put the units. X-axis is mass in kilograms. And here's the plotted points. I'm going to talk about this one on the next slide. Except for the point at m equals 0.4 kilograms, within the limits of experimental error, the value of the period does not change with a changing mass. The period of the pendulum is independent of the mass of the bob. The measurement should be repeated for this data point to ensure it was done properly. If the value remains, then a good experimentalist will search for a reason. You hypothesize that the period of the bob is linearly proportional to the length of the string now. How does the previous experimental procedure need to be modified to test your new hypothesis? The only variable that should change now is the length of the string. The angle at which the bob is released and the mass of the bob should be kept constant. Then any change in the period will be due solely to the length of the string. Step 1. Release the pendulum bob at an angle of theta less than 15 degrees, such that it is set into simple harmonic motion. The amount of time needed for the bob to complete 10 oscillations should be used, as more oscillations would help minimize experimental uncertainty. The error due to the student's reaction time is constant, and by timing 10 oscillations, it will be a smaller percentage of the measurement. Number 2. Keep the angle at which the bob is released constant. Measure the angle in the beginning and keep it marked throughout the experiment. For each of the different strings, the recorded time it takes the bob to complete 10 oscillations should be recorded in a table. 4. Conduct 3 trials for each different string to minimize experimental uncertainty. Average and plot 1 point for each string. Finally, construct a graph of the period of oscillations versus the string length. The period should be calculated for each of the trials by dividing the recorded time by 10. From the data points plotted, a best fit line should be drawn to model the data. The shape of the graph will be used to determine if the length of the string is linearly proportional to the period of oscillations.